How are you, dear students? I hope you all are fine. Today I brought you a very helping tutorial that helps you to be successful in your final exam. I can say that the main content of maths for natural science is included in this final exam. Before I dive into it, as usual, I hope you are wise enough in encouraging the tutor, subscribing it. Under this channel, a complete tutorial of Applied 2 is already done. In near future, tutor for Applied Maths 1 is to be prepared. Thus, subscribing the channel is worthwhile. Having said this about the introduction of this particular playlist, what follows is the exam prepared here. A complete solved problem of final exam on mathematics for first year students have been prepared here. So dear student, this is basically prepared for two reasons. One is just to let you see how a final exam looks like, and second, it helps you to be successful in your final grade. So let's directly go to the next slide. As you see, the final exam is having a 3-hour duration, and it was done on June 12, 2023. The maximum score allotted for the exam was 50%. Instructions are written here. You can read and understand. As you see, the final exam is having multiple choices. 6 multiple choices are given to you. It is having 1 point each. And next from that, we have fill in the blank questions. Here also there are 7 different multiple fill in the blank questions. So we are going to pass through the answer of all these. Next we have a workout part. So under this workout part we do have different questions having 6 points each. So the first one is here, the second is as you see here, and next we have the third and the fourth, and finally also the fifth application question is also written. So under this tutorial part, we are going to see how we can solve all these questions together. So let's directly go to the questions together with the answers, okay? So here comes the first one. It says, suppose you are having two complex numbers, z1 and z2, and assume that another complex number z is asserted by using z1 and z2 as 1 minus t times z1 plus t times z2 for some real numbers t, where t is between 0 and 1. If the argument of w, as a definition, denotes the principal argument of a complex number w, then you are asked to find the difference of the arguments of the two. Here, you are given these multiple choices, so you are supposed to select the right one. So the solution for this is done as you see. You have been given that z is equal to 1 minus t times z1 plus t times z2. So from this you can understand that, you see, 1 minus t times z1 is the same as z1 minus t z1. Just simply multiple z1 by 1, you do have z1. z1 with t minus t z1 and then plus 2 t z2. So look, the question you are having here says z minus z1. So we can directly take z1 to the left and can have z minus z1 in order to come to, this is the solution of the problem. So when you bring this z1 to the left, this comes z minus z1 is equal to t times z2 minus z1. Mind you here students, I just have reversed this two. This is t times z2 minus t times z1. So you can take t as a common out and then you can have this. So beloved ones, what do you understand from this? Remember students, in our classroom we studied that a complex number can be presented as a vector form on a complex plane. So consider these two as vectors. So as you see, one is a scalar multiple of the other, and t basically is positive as you see. So this shows you that, you see, both vectors z minus z1 and z2 minus z2 are parallel, and they are again directing in the same direction because we are having t to be positive value. So you see, the sketch looks like this as you see here. d minus z1 as can be shown here, z2 minus z1, they are, I see, having same direction as can be shown. So the angle between the two is going to be identical, since You see, we are talking about capital A argument of the complex number. Our angle is specifically limited to the interval minus pi up to pi. So you do have when you do have only one angle, one specific angle for a certain complex number. Because of that, only one angle is going to exist for this one. And again, only one angle, capital A argument of, you see, this complex number is going to exist. And because of this, since they are parallel and they do have unique, you see, argument measure, necessarily the two will have identical argument values. And because of this, you see, argument of z minus z1 is going to be the same as argument of z2 minus z1. They will have same argument values. The main reason for this is we are looking for capital A argument. Had it been small a argument, we could have a lot of different kinds of coterminal angles. But since capital A argument is limited within the interval minus pi to pi, we do have only one or unique angle for a given complex number. Because of that, you see, for this particular difference z2 minus z1, we have one capital A argument angle, and for this particular complex number z minus z1, we do have only one capital A argument. Since they are parallel and directing in the same direction, you see, we do have the two arguments to be identical. Because of this, these two are the same. Mind you, dear students, we are asked here to find the difference of these two identical argument values. Look, we obtained the two to be the same. Look here. So the difference between the two goes to be 0. So clearly, so long as they are the same, the difference of two similar angles makes 0. Because of this, our answer is going to be B. You see, it is under choice B that we have 0. Hence, the first question is answered. And when we go to the second one, students, the second question says you are given different eccentricities of ellipse. 4 ellipses are existing here having different eccentricities, E1, E2, E3, and E4. The common thing given here is they all are having same major axis. It has been stated here. You see, that is to say, they are having, you see, same major axis of length to A. Now, now you are asked to select the type of the ellipse that can be closest to the circle. That can be closest to be the circle. See, which do you think is the one that can be closest to be the circle? So this asks you to know the definition of eccentricity. So you have to know about the concept of eccentricity to tackle this problem. So the eccentricity of an ellipse, as you all know, is given by C over A, where C is the distance between the center and one focus, and A is the measure of the length of the major axis. Basically, it is half of the measure of the length of the major axis, or you may also consider one part of the major axis. So this is understood. The eccentricity of an ellipse refers to how flat or round the shape of the ellipse is. So from this you can understand that the more flattened the ellipse is, the greater the value of its eccentricity. So whenever you have large value for eccentricity, the ellipse is totally far away from being a circle. The smaller, you see, the smaller the eccentricity value, the more the ellipse to be closer to a circle. That is the idea. So the more circular, the smaller the value or closer to 0 is eccentricity. So what you need to do is, you see, you need to find the ellipse having smallest eccentricity value, because your intention is to find an ellipse, as you see, which can be closest to the circle. And because of this, when you compare E1, E2, E3, E4, which do you think is the smallest one? Definitely it's true. E4 is the smallest one. So, you see, the ellipse which is closest to the circle is the one having smallest eccentricity, and that is the fourth ellipse. Another way of clarifying this is this one. As you all know, in the case of ellipse, B is given by the square root of a square minus c square. Remember, students, B is, you see, the other axis of your ellipse, which you called as minor axis length, semi-minor axis length, and A is semi-major axis length. So when A and B are identical, it's going to be a circle. But here, for A and B to be the same, C has to be 0. If possible, C has to be 0. So as the value of C gets smaller and smaller, what is happening? B and A are getting to be identical. If that is so, if B is identical to A, it will be a circle. You see, it's no longer be what? An ellipse. So we have to now create a means of having small value for C. Look here, as you are having small c, provided that is constant, because it has been said here it's the same. If c gets smaller and smaller, you see the eccentricity value gets smaller and smaller. If the eccentricity value gets smaller and smaller, and c is also getting smaller, look, b and a are getting to be what? You see, the same, even though they can't be the same. So this shows you that as c approaches to 0, b is approximately equivalent to a. Hence, the ellipse with smallest eccentricity is the closest one to be the circle. And because of this, our answer is going to be B. This is all about, you see, the second question. I hope you have understood the idea in a better way.